Hello everyone, my name is Patil and today I'm excited to present our project on pneumonia detection software. The project was developed by Group 1 of Computer Science Department from DYPCET College of Engineering and Technology, Kolhapur. Our team members are myself, Vibhav Inamdar, Atharv Patil, Amaan Mulla, Tushar Patil and Rohan Powar. Our aim is to simplify the diagnosis of pneumonia using advanced technology. We have utilized the CNN ResNet 50 algorithm to develop a software solution that can detect pneumonia from chest X-rays. So first, let's understand what pneumonia is. Pneumonia is an infection that affects one or both lungs. It primarily causes the air sacs or alveoli in the lungs to fill up with fluid or pus. This impairs the lung's ability to transfer oxygen into the bloodstream, leading to symptoms such as cough, fever, chills, and difficulty in breathing. There are various causes of pneumonia, including bacteria, fungus, and viruses. While viral pneumonia can be caused by influenza virus, fungal pneumonia is less common but can occur in people with weakened immune systems. Pneumonia can range from mild to severe and can be life-threatening, especially for infants, older adults, and people with underlying health conditions. Therefore, timely and accurate diagnosis is crucial for effective treatment and recovery. Now let's discuss the problems faced by traditional pneumonia diagnosis systems. Diagnosing pneumonia involves a combination of physical examinations, medical history reviews, and diagnostic tests such as chest X-rays and blood tests. However, this process can be expensive and time-consuming. It often requires trained professionals and well-equipped medical infrastructure, which may not be readily available in remote or underdeveloped areas. The lack of access to timely diagnosis and treatment can lead to severe complications and even fatalities. Our project aims to address these issues by developing a desktop software solution that can detect pneumonia using chest X-rays. By leveraging the power of CNN ResNet 50 algorithm, our software can analyze X-ray images with high accuracy, providing a reliable and efficient diagnostic tool. This is the literature survey of our project, which contains all the research papers that we have referred to.
Working Image classification and filters. X-ray image dataset has been downloaded from Kaggle website. The image dataset has been classified as train, test, validate images. The images are then shuffled randomly and various filters such as image erosion, image dilation, Gaussian blur and Canon edge detection are used. After the pre-processing is complete, these images are used as an input for training the model. Image erosion. Erosion shrinks the image pixel. It is used to shrink or erode region of interest in the grayscale images. Image dilation. Dilation expands the image pixel. It expands or thickens the region of interest in a grayscale image. Gaussian blur. Gaussian blur is used in image processing to reduce the image noise. Canon edge detection. Canon edge detection is used to detect edge in the images. It is used to extract useful structure information and dramatically reduce the amount of data to be processed.
Convolution neural network or CNN algorithm is a deep learning algorithm majorly used for image processing and recognition. All the projects in today's world that are concerned with image processing and recognition, the CNN algorithm is famously used in that projects. We have also used CNN algorithm for our image processing, which we deal with the chest X-ray images in our project. CNN algorithm has following layers: convolution layer, pooling layer, flattened layer, and fully connected layer. Convolution layer extracts features and patterns out of the images and converts the image into a 2D array. Max pooling layer further defines a stride to the 2D array and picks up the maximum element out of the stride and stores it in a new 2D matrix, which it further passes on to the flattened layer. Flattened layer converts matrices of features into a 1D array and then it further sends the final features to and the 1D array to the dense layer. Then from there it is further sent to the fully connected layer, which is the last layer. ResNet 50 algorithm. Our CNN is based on ResNet 50 architecture. ResNet 50 is a type of convolution neural network that is 50 layers deep. ResNet stands for residual network, which refers to the residual blocks that make up the architecture of the network. ResNet 50 consists of 50 layers that are divided into 5 blocks, each containing a set of residual blocks. Zero padding, convolution, batch normalization, ReLU, which is an activation function that we have used in our project, max pool, convolution block, ID block, and such 4 blocks are there. Average pooling, flattening, and FC, which consists and makes up an ResNet 50 architecture, which then works with the CNN algorithm to detect pneumonia and to convert and process the chest x-ray images and find features out of it.
The initial step of the process is image. In this process, it involves acquiring a raw X-ray image of the patient's chest. This image serves as the primary input for the model and is crucial for diagnosing pneumonia. The second part is image preprocessing, where the grayscale image reading is done. Here, the model reads the X-ray image in grayscale to focus on the relevant intensity information, simplifying the data by removing color channels that are not necessary for medical imaging. After this, random image rotation is done. To increase the robustness of the model, the image is randomly rotated by a small degree. This helps the model learn to recognize pneumonia in different orientations. After this, image resizing is done. Here, the image is resized to a standard dimension, which is 224 by 224 pixels, suitable for the CNN input. This ensures consistency and efficiency in processing. After image resizing, random image flip and random brightness and exposure adjustment is done. The image may be randomly flipped horizontally or vertically to augment the dataset, helping the model generalize better by learning from varied perspectives. And the brightness and exposure of the image are adjusted randomly to simulate different imaging conditions and enhance the model's ability to perform under varying lighting conditions. After this, CNN model using ResNet 50 is used, where inside the convolutional layer, feature extraction and matrix conversion is done. Inside the max pooling layer, the dimensionality reduction and spatial invariance is done, where max pooling layers reduce the dimensionality of the feature maps generated by convolutional layers. The normalization layer does consistent feature scale, where it standardizes the input to the next layer, ensuring that the feature scale remains consistent across different images. This helps in faster convergence during training. The flattening layer converts the 2D matrices of features into a 1D array. The last part is result, where after processing through the layers of CNN, the model produces the final output indicating whether the patient has pneumonia or not. After this, the application architecture. Here, when we start the software, we get to see the home page. Inside the home page, if you have already registered, then you will go to the login page where you can log in to your register account. And if you haven't registered, then you will be redirected to the registration page. After registration, you will be redirected to the login page where you can log in and use the software. After login, you will go to the main page where you can insert the X-ray image for processing. Once the image is inserted, pre-processing is done on the input image. After pre-processing, the image is then transferred to the CNN module. The CNN module does the prediction by extracting features and patterns from the image and gives us the result. The result is then stored into database and displayed. After this, you can log out from your account.
The system requirements for a project are: on developer side requirements, Visual Studio Code, deep learning libraries such as TensorFlow, PyTorch, and Keras, image processing libraries such as OpenCV, chest X-ray database, good configuration system. On user side requirements are latest Windows 10 11 operating system, 4 GB or more RAM, 250 MB storage space. The technologies used in our project are: on front-end side, HTML, CSS, and JavaScript are the languages used for front-end development. The structure, design, behavior, and content of everything seen on browser screens when websites, web applications, or mobile apps are opened up is done in front-end part. Backend. It interacts with the front-end and manages the application's functionality. backend systems manage and interact with databases to store, retrieve, and manipulate data. Firebase is used for database on the backend side with coding in JS. This is where all the data, including the patient's information, login details, and x-rays, are stored.
This slide shows the screenshots of the working user interface of our application.
In conclusion, pneumonia detection project utilizing deep learning for the analysis of chest X-ray image represent a transformative advancement in medical diagnosis, particularly in resource-limited setting. This project harnesses the power of convolutional neural network to automate the identification and classification of pneumonia, thereby augmenting the capabilities of healthcare professionals and enhancing the accuracy and speed of the diagnosis. Current model employing architectures such as VGG16, Inception V3 and ResNet 15 have demonstrated high accuracy in detecting pneumonia. In conclusion, the adoption of deeper networks like ResNet 101 and ResNet 152 in pneumonia detection project has the potential to significantly elevate the pneumonia performance and reliability of automated pneumonia diagnosis from chest X-ray image. These advancements are particularly beneficial in resource-limited settings, where they can lead to timely and accurate detection of pneumonia, ultimately improving patient outcomes. As we continue to refine this model and address the associated challenge, the integration of advanced deep learning technique will play a crucial role in the future of medical diagnosis, ensuring better healthcare delivery worldwide.